EconoPhysics. EconoPhysics is the application of physics-based principles to economics, hence the name EconoPhysics. The field was established in the 1990s by a group of physicists with the intention of solving economics-based problems. They applied mathematical models used in statistical mechanics to explain economic phenomena such as extreme disequilibrium within markets. The most influential example of econophysics is the Black-Scholes model. This model is analogous to diffusion theory in physics and was developed by economists Fisher Black and Myron Scholes, who won the 1997 Nobel Prize in Economics for their work. The Black-Scholes equation is the partial derivative used to solve for options prices. Essentially, when provided with an option, a type of financial investment, the equation takes variables such as the option price, time, interest rate, and volatility of the stock market in order to determine whether the option is a favourable investment for the investor. The derivative function in maths is one which takes a value of x and returns a gradient of the original function at that point. It is denoted with d by dx. For example, d by dx of x squared is 2x, thus telling us that the gradient of this curve at x equals 2, for example, is 4. That upside down e you can see in the equation is the symbol del and is used to denote a partial derivative. This is a mathematical function which finds the derivative of a multivariable function whilst holding one variable constant. For example, if you had a 3D graph with z equals f of x and y, you could find the partial derivative of this function by holding x or y constant and therefore finding the gradient function at a certain depth or height. Armed with this mathematics, Black and Scholes created their model, which contributed to the creation of the now multi-trillion-pound derivatives market. This is the market based upon underlying assets such as stocks, bonds, and currencies. It is also believed that indecent use of the formula helped cause the financial crash of 2008, the largest global economic crisis since the Great Depression. Costing millions of jobs and tens of trillions of pounds, the UK economy is still recovering to this day. The use of maths and physics helps economists evaluate and analyse data which otherwise would be impossible to interpret. And as we have seen, this practice can have a detrimental impact on the global economy.